We've talked about addition and subtraction of signed numbers, so now let's discuss the other basic arithmetic functions. The first few pages of the book has a good process about talking about how we define multiplication of signed numbers. And in the very beginning, multiplication was really just repeated addition. So 5 times 3 is 5 groups of 3. We have 3 plus 3 plus 3 plus 3 plus 3, and adding those all up gives us 15. So using the same idea, 5 groups of negative 3, or 5 times negative 3, is the same thing. You can do plus and minus, that's the same thing as what I'm writing here. And adding these all up gives us negative 15. And also, if we have negative 5 times 3, we can use the commutative property of multiplication to make this 3 times negative 5 times negative 5. And this is just 3 groups of negative 5. And you see here we have negative 15. So what happens then if we have negative 5 times negative 3? It may be a little confusing because you can't really have negative 5 groups of negative 3. That doesn't make sense. But let's consider the following pattern. Negative 5 times 3, which we just found in this above line here, is negative 15. Negative 5 times 2 then will equal negative 5. We can flip it around, right? This can become 2 times negative 5. So it'll be negative 5 minus negative 5 becomes negative 10. So we have negative 15, negative 10, negative 5 times 1, that's just going to be negative 5. And then of course negative 5 times 0, that's going to give us 0. So following this pattern, negative 5 times negative 1, right? We have negative 15, negative 10, negative 5, 0. When we multiply 5 by 3, 2, 1, 0, what do you expect should happen for this next part? To keep the pattern going, we would expect it to be 5. In other words, a negative times a negative equals a positive. This is just a declaration we make in mathematics. Thankfully, it has stood the test of time for a very, very long time. But this is what we would call an axiomatic choice. If we were to define negative times negative equals negative, some things in mathematics would be nice, but a lot of other properties would break down. And so that's why we establish negative times a negative equal to positive, so that a lot more properties and things that we like work out nicely. So looking back at our original 4 things here, we have 5 times 3 equals 15, 5 times negative 3 equals negative 15, negative 5 times 3 equals negative 15, and negative 5 times negative 3 equals positive 15. Do you see a pattern here? We have positive times a positive equals positive, positive times negative equals negative, negative times positive equals negative, and negative times negative equals positive. In the first case, we have 2 positives gives us a positive. In the last case, 2 negatives gives us a positive. Then we have a positive and a negative gives negative, a negative and a positive gives us a negative. If you have 2 of the same sign, you get a positive. If you have 1 of each, you will get a negative. It's the same rules we used in addition and subtraction of negative numbers, well, of signed numbers, I should say. And it applies just the same way for this. And of course, whatever works for multiplication also works for division, because division is just multiplication by an inverse number. So it's the same properties. Okay, let's try these properties out on some example problems. We're just trying to find the product here and then find the quotient. So 3 times negative 6, positive times negative is negative. 3 times 6 is 18. And that's all there is to it. Negative times negative is positive. 2 times 7 is 14. Of course, we don't need to write the plus. It's assumed to be positive if there's nothing written there. Negative times positive is negative. 1 times 15 is 15. Note that I could drop these parentheses here and write 3 times negative 6. And these parentheses, I could do the same thing here, negative 2 times negative 7. But you'll notice if I drop the parentheses in both problems 1 and 2, now the problem becomes a subtraction problem. Number 1 becomes 3 minus 6, and number 2 becomes negative 2 minus 7. If there's no parentheses written, we have to have this multiplication symbol that number 3 has. It must be there if no parentheses are written. If there is a parentheses written, then you assume it would be multiplication if there's no sign between the parenthesis and the number that's leading or following. Okay, just like in this case here, we have no operation written between the 4 and the parenthesis, which means we assume multiplication. 4 times negative 8, positive times negative is negative. 4 times 8 is 32. Now this is kind of a preview for next the next section. Squaring is just where you multiply by itself that many times. In this case, you multiply by itself 2 times. If it was 3, it'd be 3 times, like down here. Negative 1 cubed is negative 1 times negative 1 times negative 1. But here we have negative 2 times negative 2, which is going to be positive 4. Okay, we work left to right. You can do this. You can do a lot of these things. You can move things around really easily in multiplication. But let's just work left to right. 5 times negative 3 is negative 15. Times negative 9 is going to be positive 15 times 9, 90 and 45, so it'll be 135. And then times by 1 is 135. You can look at all this. We have a plus, a minus, a minus, a plus. 2 negatives cancel, and you see that they're all plus now. So our answer is going to be positive. Negative 1 cubed is negative 1 times negative 1, which is positive 1. And positive 1 times negative 1 is negative 1. You see here we have, let me do it in red here. We have a negative times a negative times a negative. 2 negatives cancel, but we're still left with a single negative, and that's going to end up being in the answer. Negative 86 times 4. We do not have to calculate this because anything multiplied by 0 equals 0. You don't even have to worry about a sign because 0 doesn't have a sign on it. All right, negative 6 times negative 2. The 2 negatives cancel, and we can cross cancel. We can take out a 2 from the 6 and a 2 from the 2. And you see we have 5 times 1 is 5, 3 times 3 is 9. Okay, this one's negative 2 sevenths times negative 2 sevenths times negative 2 sevenths. Negative times negative times negative. 2 negatives cancel. We're left with a single negative now. 2 times 2 times 2 is 8, and 7 times 7 times 7 is 249, I think. Let me just check. 343. Okay, the next one, negative 1/2 times negative 1/2 times negative 3 is the same thing as negative 3 over 1. 2 negatives cancel, and we have a single negative now. On top, we have 1 times 1 times 3. On bottom, we have 2 times 2 times 1. All right, last problem for this. I'm going to rewrite 2 and 1/2 as a mixed number. 2 times 2 is 4, plus 1 is 5. And we have negative 1/2 here. We can cross cancel the 5s. And we have a positive times a negative is negative. 1 times 1 is 1 on top. 2 times 1 is 2 on bottom. So negative 1/2. Okay. Division, same properties. Negative divided by a negative is positive. 16 divided by 8 is 2. Negative divided by a positive is negative. 9 divided by 9 is 1. Negative divided by a positive is negative. 100 divided by 10 is 10. Positive divided by a negative is negative. 20 divided by 4 is 5. Negative divided by a negative is positive, so I don't have to write anything. 52 divided by 1 is 52. Negative divided by a positive is negative. And 1.5 divided by 5, I'm just going to use a calculator for that, giving me 0.3. You could also say this is 15 divided by 5, which gives us 3, and there's a single decimal point moved in, so we get 0.3. And here we don't have to actually do this division. We could. This becomes negative 1 divided by negative 2 becomes a positive because those negatives cancel. And you can just write this as 1/2, but that's also the same thing as 0.5. Okay, this problem right here, this cannot be simplified, right? So we could actually do the division to find a decimal point. But what I can also do is write this like this. I can move the negative, because a positive divided by a negative is negative. So I could say negative 3/4. That's the same thing as saying a negative divided by a positive. So what you're going to see here is that if you have a single negative, you can actually move it out in front or move it to the top if you want. And of course, you can move it to the bottom if you need to. That's a handy trick when you're doing more in mathematics, is you take that negative and you can move it around. You're not changing the number at all when you do that. You're just changing kind of where the negative goes, and you're not actually, making any kind of false statement. It's all the same thing. They're all equal to negative 0.75. But it can be helpful to move it to either the front or to the top. A lot of times we don't move it to the bottom because the denominator we don't want to have be negative and a lot of other things. You can see here that this is the same thing as that, right? I wrote it right there. This is negative 0.75. Okay, we have order of operations here. You always think of a fraction bar that's written here as having parentheses on top and bottom. We always solve those things first. When we have two negatives right next to each other, we change it to a plus. We have negative 6 plus 1 over 5. Again, think of it as parentheses on top and bottom. Negative 6 plus 1, those are different signs, so we're going to subtract. 6 minus 1 is 5. And negative 6 is the bigger number. Well, 6 is the bigger number, so it's going to be negative 5. It takes on whatever the bigger number sign is over 5. Negative divided by a positive is negative. 5 over 5 is 1. Negative 1 is our answer there. 7 divided by a fraction. We never divide by a fraction. We multiply by the reciprocal. I'm going to write this as 7 over 1 times negative 3 over 1. Positive times a negative is negative. 7 times 3 is 21. 1 times 1 is 1. And we get just, I'll write it down here, negative 21. Okay. First thing here, I'm going to rewrite this as negative 0.3 times negative 0.3. That's what the square does. Okay, now let's simplify the top. 2 times negative, positive times negative is negative, times another negative makes it positive. These two negatives cancel each other. We have 2 times 0.3 times 0.3. gives us 0.18 over negative 6. Positive divided by a negative is negative, and 0.18 divided by 6 is 0.03. All right, now we're moving on to some application problems. To convert 17 degrees to Celsius, we need to perform the following calculation. 5 over 9 times 17 minus 32. So what is the Celsius of that? 5 over 9 times 17 minus 32. We do parentheses first. 17 minus 32. They're different signs. 17 is positive, 32 is negative, so we're going to subtract. That gives us 15. Yes, negative 15, because 32 is more negative than 17 is positive. Now we have 15 over 1. And we can cross cancel. 9 divided by 3 is 3. 15 divided by 3 is 5. We have a positive times a negative becomes negative. 5 times 5 is 25. 3 times 1 is 3. Negative 25 over 3. We typically don't see improper fractions as degrees. We actually do the division, and that gives us negative 8.3 repeating. I'm just going to write it as negative 8.3. Okay, to convert between negative 8 to degrees Fahrenheit, we need to do this calculation. Just to write it out to make sure you understand what we're looking at. We have 9 times negative 8 over 5 plus 32. Okay. 9 times negative 8, positive times negative is negative. 9 times 8 is 72. And I'm going to not add two improper fractions. I'm going to actually change the negative 72 over 5. I'm going to do the division because, again, we don't really have degrees in a fractional form. We have it in a decimal form, if anything. So negative 72 divided by 5 gives us, well, it's going to be negative first off. Negative divided by positive is negative. Negative 14.4 plus 32, which gives us 17.6. So from the top one, we have 17 degrees Fahrenheit is the same thing as negative 8.3 degrees Celsius. And then negative 8 degrees Celsius is 17.6 degrees Fahrenheit. Which makes sense, right? 17 goes to negative 8.3. We have a little bit lower. We have a little bit lower of a temperature. 17 degrees is lower than 17.6 degrees Fahrenheit. And 8.3 degrees is a little bit lower than negative 8. That's because negative 8.3, right? The bigger the negative number, the small, you can think of it, quote unquote, smaller the number is. Okay, we have the first 4 months of a year. First 4 months of the year, a country had an average monthly trade of 16.5 billion. During the final 8 months of the year, the country had an average monthly trade surplus of 5.3 billion. What was the overall trade balance? So if the first one was an average monthly trade deficit, and the second one was an average monthly trade surplus. The yellow is a deficit, meaning a negative, and the orange is a surplus, meaning positive. So if for the first 4 months we had an average deficit, that's going to be a negative 16.5 billion. So this 16.5 isn't just $16.5, it's $16.5 billion. So our answer in the end is going to be in billions of dollars, not just dollars. And then we had we're going to add this to an 8-month average monthly surplus, so positive, of $5.3 billion. The total balance is going to be the addition of these two things together. Positive times a negative is negative. 4 times 16.5 gives us negative 66. 8 times 5.3 gives us 42.4. And then subtracting those two numbers, it's going to be negative because 66 is a bigger number than 42.4. So we can subtract. That gives us negative $23.6 billion. All right, due to the relative size of two connected pulleys, pulley A turns 1.5 times more than pulley B, and in the opposite direction. So if positive numbers are to indicate counterclockwise revolutions, so going this way is positive, going this way is negative, we need to express the sign number for A and B. Now this convention where counterclockwise is positive and clockwise is negative, that's very common in mathematics. There's a lot of reasons for that. But that's the convention that they always use. Okay, to kind of give you an idea of what we're looking at here, is we're looking at two pulley systems where A is going to be smaller than B. Now obviously my drawing is not going to be to scale, but it's going to look something similar to this. And then we think about like a rope that we have on this. I'm going to do it in red here. The rope's going to go over A and then down and around B like this. That's what gives us the different rotations, right? If the rope's going to go this way, it's being pulled that way, then that means A is going to rotate this way. And you see that B is going to end up rotating the other way, and vice versa, right? If the rope is pulled the other way, then the two things flip its rotations. So that's what we're looking at here. And at the amount of times that B turns, A turns faster. That's because B is a bigger pulley than A is. Okay, so if pulley A, what is the signed result for pulley A when pulley B turns 80 revolutions counterclockwise? Counterclockwise was the positive, so we know pulley B is going to be plus 80 revolutions. What's pulley B? Well, to find that, all we have to do is take the ratio that's given to us 1.5 times more. If pulley A turns 1.5 times more than pulley B and in the opposite direction, all we're really doing here is taking pulley B's result and multiplying it by negative 1.5 times. The negative is what flips the rotation, the direction of the rotation. Okay, positive times negative is negative. And 1.5, this is the same thing as 3/2. So I'm gonna write this down like this: 80 times negative 3/2 over 1. This gives us, just cross canceling there, by 2. Positive times negative is negative. 4 times 3 is 120 over 1. So pulley A does negative 120 revolutions. So 120 revolutions clockwise when pulley B turns 80 revolutions counterclockwise. Now, for part B, we know what pulley A does. Pulley A turns 60 revolutions clockwise. So negative 60 revolutions. How many turns does pulley B turn? Well, first off, we know that pulley A always turns more than pulley B, so we're going to have a number, we expect a number that's smaller than 60. We also know it's going to be positive because they change orientations. The way we do this is quite simple. all we have to do is divide this time by negative 1 1/2. The reason why is because to find A, we multiply by negative 1 1/2. To find B, then, we have to do the opposite operation because we're trying to find the different pulley. The original orange thing says pulley A turns 1 1/2 times more than pulley B. So for the first operation, we had to do multiplication. To find the opposite way, pulley B instead of pulley A, we need to do the inverse operation because it's the kind of the inverse direction. We're now going this way rather than the forward direction. I hope that makes sense. So we take negative 60 times, we're dividing by negative 3/2, so we're going to times by 2 over negative 3, multiply by the reciprocal, and cross cancel. Negative times negative is positive. 20 times 2 is 40 over 1. This gives us positive 40. The number is smaller, like we guessed, and the sign is opposite, like we also need. Okay, we have a metal rod changes in length by 0.4 millimeters every centigrade change. If it expands when heated and contracts when cooled, what is the change in length as a signed number if the temperature changes from 12 degrees to 4 degrees? So 12 to 4 degree change, that means the metal is being cooled. So it's going to contract, and it's going to contract by, contract for when it's going through a change of 8 degrees, right? 12 minus 4 is 8 degrees. We're getting 8 degrees colder. And we know that if it contracts, it's going to be a change of negative 0.44 millimeters every 1 degree centigrade. So that means for 8 degree change, we're going to do negative 0.4 times 8. That gives us negative 3.2 millimeter change. And this is going to be a negative number because we kind of think of it as the length of the metal rod is being shortened, or it's being like taken away from, if that makes sense. If it were to expand, it'd be a positive because we're adding to the length by heating it up. That's why it's a negative number, and it's 3.2 millimeters. Here's an airplane descending this amount of, from 42,000 feet to 18,000 in 12 minutes. What's the rate of change in feet per minute as a signed number? So on top, we need how much did it actually descend? The way you can do this is taking the final minus the initial and dividing it by the time it took to do that, which was 12 minutes. This is going to be in feet, and this is going to be in minutes. This is feet per minute. And you'll notice 18,000 minus 42,000, that's going to be a negative number since 42,000 is greater than 18. And we can subtract it, giving us 24,000 divided by 12. And this is going to be feet per minute. And actually doing that division, we end up getting negative 2,000 feet per minute as a unit rate. And we didn't have to worry about the sign because if we take final minus initial, it tells us that this is a negative here. That means we are descending the plane. If we had final minus initial and it was positive, that means we would be ascending. It would be like 42,000 to 64,000. That would be an ascension. And that would end up being positive because we did this final altitude minus initial altitude. Final minus initial is a very common thing to use in mathematical application problems. So keep that in mind.